Okay, let's start. So my name is Ivan. I'm a 3D technical artist in UNIGINE, and today's stream is about the material graph editor, which is a very powerful tool in UNIGINE. It actually gives a lot of freedom to 3D artists, but of course it takes some knowledge to use it. And I must say that this stream is mostly for beginners, so it's kind of a brief information, a beginner's guide. I believe that like more complex topics will be covered in the next video tutorials or streaming. So yeah, but basically, yeah, again, so it's about basics things related to material graph. And I will deliberately not show any complex stuff related to material editor, but I'll try to cover like the main brief info about it. So I have a scene right here in UNIGINE, like with the city. I've prepared just a small piece of content here for this stream. So let's just start with this building. It's like a wall made of painted brick or something. It's a pretty simple material here. It only two decals, I believe, are being projected onto this wall. Let's just recreate it, and by that, let's get a little bit closer with material graph editor. So you can create a new material just by opening up context menu inside the asset browser here. If you go to create material, you can see the three options here. Inherit from base material is a legacy, and we have two options here regarding material graph. So it's actually the graph itself and the subgraph. I will tell you a little bit later what the subgraph is. So right now, let's create a material graph. Let's give it a name, just a second. Again, simple brick wall. Let's double click on it, and you can see the window with material editor. Let's just stuck it somewhere here. So let's just delete this default nodes and default parameters so we could start from scratch. So basically, this is the main working area here. On the right side, we have settings regarding type of material. So by default, it's Mesh Opaque PBR. We have these options here, and we'll cover it a little bit later, like most important of them, of course. Some checkboxes related to tessellation two-sided, and a parameter window here. So first of all, by default, we have this main material node, which has a lot of inputs here. And as you can see, each of this input, like they have different colors, and these colors, they actually mean the format. So for example, let's just create a SampleTexture node. So as you can see, within the input of UV, we can see the green, greenish input here, green color means that you need to connect float 2 value here. Blue one, I believe it's float 3, and purple is float 4. Float 1 is red. So first of all, if we need to sample a texture, to use some texture of bricks, for example, we create this SampleTexture node, or we can just go to textures and drag and drop any texture here. And as you can see, we also have this SampleTexture node, and we have vertex UVs already plugged in here, and the texture itself plugged here in texture input. But the thing is, if we want to be able to go into the material and through the interface of the material, we want to assign different custom textures here, we need to create a parameter. So right here, there's a window with the parameters, and you can add them, duplicate them, delete them, move them up and down within the hierarchy. So let's create a new parameter. Let's you can choose a type here of the parameter. So first of all, we want a widget, like an ability to assign our own texture into the material. So let's choose texture 2D and name it, let's say, bricks albedo. Press OK. So, and if we select this parameter here, we can see some settings here. So by default, for example, it uses white texture. So if we press this button here, we can see that this is the 16 by 16 fully white texture. Let's drag and drop it here and connect it to the texture input here in the sample node, in SampleTexture node. And about the UVs. So actually, by default, this node uses UV channel 0. So if we press a space bar, we can see all of the nodes that are available inside the material graph. And if we try to type something like vertex UV, you can see vertex UV 0 and vertex UV 1 here. So if we just choose the first one and connect it, this will be the same, absolutely the same as like that. So by default, it just makes our work easier. Just we are able not to connect, not to create this node and connect it here. So we need to connect this result with the main material node. But you can see the difference between the colors here, output here and input here. Here is float 4, because obviously we could want to have an alpha channel inside our texture, right? And when you try to connect them, you have this kind of options, and it's basically, if we use an albedo here, if we connect it to albedo, so it's a good idea to just choose 3 components here and ignore the fourth one. If we want to use alpha channel for something, we could just drag from the output here, drag this connection and choose alpha channel here and use it only here, for example. So let's just save and try to see what do we have. Yeah, well, one more thing. We created this simple brick wall dot M graph, right? Right now we can assign this graph to the wall, but we won't be able to change anything inside it. To do that, we just need to inherit or create a child material from this base material. If you go to materials here, material hierarchy, you can see that here's our material, base material. We can just press create child or press the button here. Thus we will be able to control the parameters which we exposed in our graph. So let's just assign this material. Right now, by default, as I said before, we have a white color, just flat color. Let's go here. We can assign our own texture. So let's just assign it here. Here we go. That's only an albedo component. And this texture actually is like desaturated because, for example, we would want to create different types of this bricks with different color. So we're just able to multiply it with some color and make different variants of our brick material with the help of one single texture. So let's just try to colorize it. What we need to do is we need to create a node color, float 3, right? But if we do this, we only can assign like or type like a single texture at once, a single color, I mean. So basically we need to create the same thing through the parameters. So choose a type color, let's call it bricks color. Okay, by default it will be white, it is okay. And we need to just multiply it. So let's create a node multiply. So when I said about this changing here, when you input something and just cuts like unwanted components, it is better to do it like as soon as possible. So basically we can either drag the connection here or just unplug it here and connect here. Yeah, actually every node can be folded, as you can see here, just for convenience. So let's connect the result into the albedo. Let's save it. And right now we can choose the color we want. Let's just create something like this. Okay. What we want else is like a normal map and a roughness, right? So right now we only right now we only have an albedo something went wrong. Only have an albedo component, but we need to we want to assign a normal map and roughness texture, right? So let's go here. Let's duplicate this sample node. Let's create a parameter for our normal texture, which will be texture 2D parameter. Let's call it bricks normal. Okay. And yeah, by default we have that we have this white texture, but with a normal map texture it would be better if we had like basic normal texture, which is actually just a flat normals 16 by 16 pixels. Let's drag and drop it here, assign it here. And here's the difference between albedo and normal. As you can see in the outputs of this node, we have tangent normal. So basically we need to connect it to normal tangent space. And some nodes actually have additional parameters. When you double click on them, you can see, for example, here, options for MIP mapping and options for normal space when we work with normal textures and normals. That is actually pretty simple. So when we just want to use the normal orientation, normal space from different UVs, or for different UVs, sorry, we can just choose 0 or 1, but right now we won't be covering it, so let's just skip it. And we want, if I remember, I have shading texture for these bricks. Yeah. So we can just create another texture and call it bricks shading. Okay, white default texture will be fine. Let's duplicate this, connect it, and actually we can fold this just so that won't. Oh, sorry. Yeah, something like that. And we want to control the roughness through some kind of a multiplier, like just with the slider, right? We could do this by creating a new parameter slider by default, and let's call it roughness, or bricks roughness, yeah. As you can see, by default the value will be 1, minimum to maximum is from 0 to 1. It doesn't mean that we won't be able to overpass this this border. It just means the default borders for the slider. So let's just bring it here, just move a bit, and we need to multiply our texture with this slider. But I know that within this bricks shading texture I have 3 channels, and actually the roughness information is inside G channel, right? So I can basically just choose only the Y component here and multiply it with this, and then connect the result with the roughness input. Let's save and see what we have. Okay, we can now assign bricks normal. Just a second. Yeah, there we go. And we can assign this shading texture here. So if we go to debug buffers here, we can see opacity world normal, we can see roughness, and that's it. And via this slider we can control like the roughness multiplier. Oh, we can overcome this like 1 value. It will work still. So that's the basic thing, but let's say we want to mix this bricks texture with something like to add some regularity. So for example, just to add some patches of dirt or spots of I don't know, anything, or just mix with other pattern or something like that. So what we need to do here, so basically let's just try to create additional parameters. So let's create texture 2D and call it maybe dirt mask, for example. Because it's a mask, let's assign the default texture as just a black texture here. We can duplicate this SampleTexture node here, assign a texture, and we want to actually blend them by alpha. So let's just lerp. Let's just create a lerp node. We can delete it for now. Connect this main albedo bricks texture, and actually this texture here, this dirt mask, we can use it as a value, and by this value two of the textures will be mixed. Or let's say you can you can put a texture here, but let's just, for example, put a color there. It doesn't actually matter. So let's call it just dirt color, for example. And we mix this texture with the dirt by this mask. And I only need like a black and white texture for it, so single channel texture will be fine. So let's just choose X here and connect this with the albedo input in our main material node. Let's save. And let's assign the texture here, which actually, well, this texture is actually has 3 channels, but we only need 1. What do we need to do? I want to be able to control the size of this mask and probably the contrast and intensity of this dirt, right? So let's just try to first, let's just try to change the color. For example, we would like to have some, I don't know, pretty dark dirt here on the wall. And there it comes the UV, because we want to control the styling of this texture, right, of this mask. That is why we need to create this vertex, this vertex UV0 node, and we need to actually multiply it with float 2, because we know that our UV0 is float 2, right? And I want to control it from here, from the interface. So let's create a parameter. Let's choose float 2 type and call it like dirt tiling. Yep, and connect the result with the UV and then save. Let's see. So right now we can change the size of our texture. Let's just change it to something like maybe this. Yeah, right now we only change the albedo. Actually, if you want to offset your texture, you can just use the node add and add some float 2 parameter to this result, and then connect it with the UV. But I believe we have a panner, yeah, UV panner node, which is actually just, which actually does the same like here, and it moves it through. It moves it with time. Oh no, sorry. I just get confused. We have tile and offset. Yes, separate node of tile and offset. Yeah, sorry for that. So it basically does the same thing. If we do this multiplying and add some float too, it will be the same thing. So it just prepared an advanced node, and you can use this node if you want to. And the panner node, yeah, which I showed you before, is just so this node just moves the UV, so it offset it depending on time, and you can control speed. That is it. So what we want next? We want to control intensity and contrast of this mask, right? So through the material interface. So let's just go the simplest way. We have power node, and we can use multiply node too. We can connect X component with the power and add new parameter slider type. Let's call it dirt. Let's call it dirt contrast. It's not really contrast, but let's call it like that. Plug it here. And another parameter, let's call it dirt intensity. Okay. Connect, and then put it here. So let's save. Yeah, and right now we can change this dirt contrast. For example, let's overpass and like put the 3 value here, and we can make this dirt less visible. So maybe I want this to be like dark red or something like that, dark green. Doesn't really matter. Yeah, here we go. And let's maybe add some roughness parameter. Let it be a slider. Let's call it dirt roughness. And what we actually need to do is just repeat the same stuff. We can lerp it with this result of roughness. We can lerp it with our newly created slider, and use this as a mask, and connect it with roughness input. Let's save. And if you go to debug mode here in roughness, we can see that right now we can control separately the roughness of this dirt. We can go up even, maybe something like this. Yeah, that's it. So yeah, that is the main principle. So let's try to create something a little bit more complex. So let's say we want to cover these bricks with additional layers, something like plaster or concrete layer, which covers these bricks, and then it is painted, and then it is covered by dirt. So for example, like that, something like that, yeah. So there's a pretty cool feature inside the material graph, which is called portals. You can create it here, portal in and portal out. What it does, it actually allows you to save a lot of space to like to create your graph less difficult visually. I mean, so you could ignore a lot of useless connections because, for example, right here, for example, yeah, we have this result of a mask which goes like in two different places, right? And these lines, these connections, they start to overlap each other and something like that. What we can do, we can unplug it here. We can move this so it won't messing around. And with this node, portal in, we can change the color just to see it better. And we can change the name for our convenience. Let's call it dirt mask, right? And plug the result here. And we want to use this mask, so we actually can create portal out node. And if we have a lot of portals, we can just double click on the portal out node and choose the right one. So right now we only have one. We can plug it here, then just duplicate it and plug it here. Okay, save. Nothing changed visually, so let's continue here. I want like an additional texture for this concrete or plaster layer, right? So let's oh yeah, and I forgot to say, if you have some question, I'll try to answer them only at the only at the end of the stream. So yeah, let's just duplicate the SampleTexture node. Create one more thing. Sometimes, well, pretty often, the number of parameters here becomes pretty big, and it's not too convenient to work with them either here or there into within the interface of the material. So we need a special, like we have a special type of parameter, which is called a group. You can call it like bricks with the small ones. And let's put it up here. And you can move all the parameters related to bricks into this bricks group parameter, like this. And let's do the same with dirt, actually. Yeah, we actually don't have multi-selection here. Yeah, that's it. So if we save, we could see that right now we have this folding group here, and it will be much more comfortable to work with it. So let's just create another group and call it plaster, I believe. Okay. Then we want to create a texture parameter for the plaster. Let's call it plaster albedo. Okay, and put it inside this group. Connect this. And we want our dirt to be above like the plaster and the bricks layer, right? So here we blended our dirt with the bricks. So we need to blend plaster and bricks somewhere here before the dirt, right? So let's just create a lerp node. I actually want it to be like this. So I blend the bricks with the plaster. But yeah, actually I can just connect it here, but probably I would want to control the color of this plaster, so let's just create another parameter and call it plaster color. Move it into the group, multiply with the texture. Don't forget about this, we need only 3 components. And plug it here. Yeah, let's save it. And we want some kind of a mask, right, for it. So let's create it somewhere there and then put it through the portal. We need to create another texture 2D parameter. Let's call it, oh, I call it plaster albedo. Yeah, let's call it plaster mask, right? Put it inside the group. Let's just duplicate SampleTexture node from here. And for now it will be fine. We need only X component of this mask. Let's rename it just for our convenience. Plaster mask. Let's create portal out, choose plaster mask here, put it, oh sorry, put it here into the lerp node. Let's organize it a bit. And put the result here. And let's save it, just to see what do we have. Okay, so right now by default all of these textures are white, so let's go to, I have this concrete texture, concrete albedo, let's assign it, and let's assign, I have this actually just cloudy noise, let's use it as a mask, the plaster mask. Yeah, so right now of course it's too small, we need to control the size of it. Let's go create float 2 parameter. It will be plaster mask tiling. Let's create UV0 node and let's multiply them. Let's save, and let's try to control the size. I don't know, maybe this will be okay. Okay, let it be here. So I want actually to control the contrast of this mask, right? But let's say, suppose I want to control the size of this pattern, size of this spots of plaster, and I want to be able through one slider create like fully covered with plaster wall and like a clear bricks wall or something between. There are a few ways to do that, but like we can just try to use a step node. So what step node does, it actually takes our texture, right? And for example, we know that this texture is represented as a specter of values from 0 to 1, right? And if we input here into the step node, for example, value of 0.5, everything below this value will be cut out. So let's just create a slider and call it probably plaster amount, maybe. Okay, put it into the group, connect it here, and connect the result here. Let's save. And let's see what we have. So right now, I believe we can control this amount of the plaster. Well, for now it's just a color. But what if I don't like this two sharp edges of this pattern? I could use, I believe, smooth step node. Yeah. The difference is, so let's try to delete this one. The difference is that we can just plug into the minimum here something like and that is like another cool feature. We want these inputs to differ, right? So we can just we can do the expression here, do some math. For example, we want to subtract something like 0.2 and just connect it here. Let's save, and it will give you this like transition between the values. Right now it's too blurry. Let's like make it 10 times smaller. Oh, sorry. Save. Maybe something like 3 here. Save it. Okay, that will do. Okay, so what we need to do actually, I would like this, so let's just change the color. So for example, like try to use almost the same color as the bricks. Maybe something like this. What we want to do actually, we don't want to see this bricks normal texture where these patterns are, and we actually want to have this like volumetric bumped edge here around these patterns, right? It actually would be easy to do if we used like a static pattern here, because we could just assign some normal map, static normal map of this pattern, right? With these borders, with the slopes on the edge of this pattern. But we want to control this actually in real time. So that is why we can use a node which is called, I believe, normal from texture and normal from value, from height value. Yeah. So let's just disconnect this node from normals, and let's try to, as you can see here, we have inputs of height value and height in meters, and those two, they actually use some information by default, just like with the UV here, which I mentioned before. But we need to know the height, right? And actually we have a portal here with the plaster mask, and let's try to use this mask as a height. And let's say we want to control the normal intensity of this pattern of plaster. Let's name it plaster normal intensity. Put it here. Let's say it will be 0.1 by default, for example, and save it. Nothing happened because we forgot to plug it in. Connect it with normal tangent space input here, and then save. Yeah, and right now we have a pretty strong normal. Let's just decrease it a little bit, maybe something like that. Yeah, as you can see, if we go to opacity world normal here, we can see that right now we actually getting a pretty nice slope on the edges of this pattern. But we disconnected bricks, and we actually wanted these patterns, these spots, to be not flat, but with some kind of concrete or plaster normal, like rough normal with bumps and cracks and something like that. What we need to do is actually we have this normal here, right, of this spots, big spots of plaster, and we want to blend it with some normal texture for plaster, right? So let's create an additional texture to the parameter and call it plaster normal. Let's put it somewhere here. Plaster normal. Let's duplicate SampleTexture node. Oh yeah, and sorry, we need to, don't forget to change it to normal by default. Let's save. And we don't want to like erase the normal of these edges here, right? We want the normal of the concrete or the plaster to be on the top of this pattern, these spots, right? And that's why we have a node which is called, I believe, reorient normal blend. Yeah, and you basically put, let's just swap them, and we basically connect base normal with the detail normal and connect it with normal tangent space, save, and let's assign a texture of the plaster, concrete building N. Okay, that's fine. Yeah, as you can see, it works, but right now we have this normal texture everywhere, and we need to have here normal texture from bricks. That is why we can just lerp our main brick normals with the plaster normals and use as a mask, of course, plaster mask. Let's connect it here, move it a little bit. And I don't like that there's too much of the node here, so let's just move it here and create a portal, and let's just change the color so we could better recognize it, and change the name of it to not plaster normal, just like overall normal. Connect it here, And here, let's move it a bit. You can create a portal out node and call it, and choose the normal, connect it here and fold it and save. So right now we have what we wanted in terms of normal map. Here we go. And let's just change the roughness, because the roughness stays the same. We can do it pretty easy the same way. So let's just lerp this result. Oh no, sorry, we need to lerp it before dirt. With the roughness parameter of our plaster roughness. So let's not use a texture, just use a regular slider. And we need a mask. Portal out, plaster mask. Use it as a mask here. And connect this to our dirt. Plug it as a roughness. Save it. Let's see what we have. And here in roughness debug buffer, we can see that we can change actually the roughness of our plaster. Actually, we use it as a mask, yeah. Just a second. Plaster roughness. We'll lerp it with plaster mask. Plaster roughness. Oh yeah, it's actually correct. Yeah, because we have this roughness of the dirt on top of it. So actually it's correct. I believe this is it for this particular example. So this was like a simple way of blending like multiple layers inside the opaque. You remember this opaque PBR material? Let's try to change the type of the material and see what we else have. For example, I have a tree here, I believe. Let's just drop it. And let's say I want to create these leaves. I need alpha test obviously for it, and translucent, and two-sided. So let's try to recreate this and see how it works. It will be actually pretty easy. Let's go create a material graph and let's call it leaves, tree leaves. We need to create a child of this material. Let's go here and assign. We have 3 LODs for this leaves. Let's assign the material to them. So right now it's obviously not two-sided, not alpha test. So let's open up this material. Let's delete metalness because we don't need metalness within the tree. Let's change it to Mesh Alpha Test PBR. And right now you can see that when we change this type here, we're now able to use some additional inputs here on the main material node, which actually opacity and opacity clip threshold. So let's try to, oh yeah, by default, as you can see, we have a texture here, albedo texture, and a color multiplier. So let's save it. Let's try to assign textures. As you can see right now, we don't use any alpha information of this texture. That is because right here, with the new inputs here, we can use an opacity input, and we can just connect the SampleTexture node with opacity and choose alpha. And let's save. Right now it should be fine. Yep, it is. And just a second. What else? Normal map, right? I didn't assign it. So let's assign a normal map here. And we want to be able to control translucent. As you can see, we have this input here. Let's create a slider parameter and call it translucency. Okay, just connect it with the translucent input here and save. And right now it's working. Yeah, we can see. Actually, I believe we have a debug buffer here for translucency too. And and the final thing, we want this leaves to be two-sided, so it's just simple checkbox here. We can check it and save, and it'll become two-sided. Pretty easy with that. Let's just continue with, for example, with tessellation here with this checkbox. I have a palm tree here with tessellation on the trunk. Yeah, here we go. Yeah, and as you can see, on this part of the trunk, we have these flakes, which were displaced and previously tessellated, of course. Let's just try to repeat this, and actually if you select this, you can see the density of the mesh here changing dynamically depending on the distance of the camera to the camera. So let's just try to create our material, call it palm tessellated trunk. Let's create a child material and assign it. I believe we have, of course we have 3 LODs. Let's assign this newly created material to them. Oh no, it's not that. Tessellated trunk. Tessellated trunk. 0, this one. Oh yeah. Sorry. So let's open up a material. Again, we don't need the metalness for this tree. Let's just save it and assign basic textures, albedo and normal, right? So bark, albedo, bark, normal, and just change the roughness, something like that. So right now we need to turn on the tessellation. So just check this tessellation here, and as you can see, we are now able to use additional inputs here: tessellation factor and tessellation vertex offset in tangent space. I'll try to explain it right now about tangent space. Well, it's actually pretty easy. Let's create a texture parameter for our height map, which we'll be using for displacement. So let's call it height. Yeah, just height. Okay. Probably it will be a good idea to have it by default as a black texture, because we don't want to displace it by default. And let's create SampleTexture node. 0V channel by default, so we don't need to change anything. And the interesting thing starts here, because yeah, first let's just be sure that we'll be able to control the amount of the displacement, right? So let's create an additional slider parameter and call it displacement scale, probably, and multiply it with the X component of the texture, because I know that I have one single channel texture here, which is actually normalized. Height maps should be always normalized, so they need to contain like a whole spectrum of the values from 0 to 1. So connect here with X, and there's an interesting thing here. We need to connect it with the input of tessellation properly, because we need to displace our vertices only along their normals. So basically, if we just plug it in right here and save, let's see what we have. Let's assign a texture, height map, and we control the displacement scale. As you can see, the vertices here on these flakes, they start to displaced. They starting to be displaced not only outwards the trunk, but they actually are getting displaced by all three dimensions. And we actually in tangent space, so we actually want them to be displaced only by Z component. So what we need to do, we are getting X from here, right? And we put the X to the third of Z component, right? And put zeros in X and Y component. That should be enough. Yeah, right now it works properly. We can control the scale of our displacement. But there's one thing here. We would like to control like the midpoint of this height map, right? So we don't want this trunk to be displayed by the displaced outwards by the whole spectrum of values in this texture. We want our displacement of this trunk to start from the 0.5 values of this texture. It will be pretty easy to do. There's a node which is called rearrange, which is a very helpful node actually. What we need to do is we just like pass the value here into the input, right? And we know that by default our texture is normalized, so the values there are from 0 to 1, but we want them to be, for example, we want to move the lower border, so for example to minus 0.55. So let it be like this, and let's leave it 1 here. actually. Okay, save it. And this, oh sorry, something went wrong. Oh yeah, forget to, sorry I messed this up. We need to rearrange the value of the texture before we multiply it, of course. That's my bad. Save it. Yeah, now it became better. As you can see, we don't have this part of the trunk stacking from or above this bottom part of the trunk, and we can see that displacement just works properly. The parts with the darker colors on the height map is actually are actually being like bumped inside, so pushed inside of the trunk, and the brighter colors are pushed outside. Yeah, and actually there's an additional input here with tessellation factor, so we could just create a slider and call it tess factor. Okay, let's connect it just here. Save. And we can see it through this one. Let's just tweak it, and you can see how the density of the tessellation changes. Actually, in the base options of the material, every material has a base options here into this interface, so it doesn't mean if it's tessellated or alpha test or alpha blend, something like that. Into the base options here by default, we turned on tessellation. That's why tessellation here appeared, tessellation parameters here, and we have some additional features like we can choose to render or not to render our tessellated meshes, our tessellated geometry into the shadow map, and we can tweak density separately from tessellation factor, and change the distances just in order to control this behavior of tessellation. So that's it about tessellation. Let's continue. Let's continue with the decal, actually. Yeah, that's another type of material inside the material graph. Well, you can choose another type of material. So let's assume that I want to create some area covered with puddles or something like that. Let's create a decal. Let it be Ortho Decal. And I want to change the size of it. Something like this, maybe. Rotate it. I think that will be fine. So I want puddles here to be here. Let's create I have a separate folder here. Yeah, let's create a material, call it puddles new, for example. Create a child material. Right now we actually we created a child material, right? And if we want to assign it, it won't work because inside the material editor we need to change the type of material to Decal PBR and save it. And right now we should be able to assign it. Yep. So basically, again, we don't need metalness for now. What I want to do, I don't want to use any albedo texture, so let's just delete it and delete the parameter here. I only want albedo color, for example. Actually, when we change the type of the material here to the Decal PBR, we have a lot of a lot of additional inputs here. As you can see, opacity, like overall opacity for the whole decal, and separate opacities for albedo, roughness, and normal, and auxiliary person. So let's start by creating some kind of a pattern of these puddles, right? I believe I have like the same texture as with the billion, yeah. Let's create a texture 2D and call it puddle mask. Okay. It will be black by default, I believe. Let's put it black, yeah. Create a sample node. Oh, I shouldn't delete the previous node from albedo. Okay, doesn't matter. And I want actually my color to be send it into albedo, right? Yeah. And I want this texture, this mask, to control the opacity of my albedo here, right? I'll explain later why we don't connect this mask to the whole opacity. Okay, so now I want to not only to be able to use a mask to create this kind of a pattern, right, for albedo. Right now we're talking only about the albedo, but I want to be able to control the intensity or the amount of this albedo color, like right with puddles. Obviously, when the surface is wet, it becomes like a darker, and albedo becomes darker, and that's why we want to control this like a level of darkness or something. So let's just multiply this X component of this mask, because it's single channeled, obviously, and in the albedo, actually, in this widget of albedo in the interface of the material, we have an ability to use alpha. So I can just connect an alpha component from our albedo color node, and then as a result connect it with an opacity of albedo. So let's save it. And right now, if I choose my decal, I can assign puddle mask here, and probably let's just create a black color for albedo. And I don't want it to be this intense, so let's just drop it by something like that. Of course, I want to control the size of this mask, so let's choose float 2 mask, or no, puddles tiling. And yeah, vertex UVs, right? But we use Ortho Decal. So basically, it doesn't have any mesh or vertices inside it. So that's why I believe we have separate nodes for decals. Oh no, I'm wrong here. I guess, yeah, I guess we can use vertex UVs here, but there is a trick with decals, and yeah, let me like show you it right now. So if we just connect vertex UVs here with the UV of a sample node, we can control as usual the size of it. Yeah, it works pretty fine. I just confused it with another moment. I will show you it right now. So right now, as you can see, this pattern moves, and if I change the size of a decal, it will be stretched. And if I don't want to stretch it, I can use world coordinates instead of UVs. But the thing is, when we work with meshes, we just use position, vertex position node, and change it, for example, in absolute world here, right? But with the decals, we need to use a separate node, decal scene position, I believe. Yeah, and we can change the same, the similar way to absolute world position, and we can just use X and Y components, like a horizontal components, right, of this node here. And the thing is that thus we'll be able to move it and maintain this pattern, and actually create something like seamless, and rotate it and change the size of it, not worrying about this distortion, stretching, and something like that. Well, let's just continue with the world coordinates. Let me just change the size because of the world, because this is the world coordinates. I need to change the tiling here. Okay, that's it. So I need to control this contrast of this pattern the same way we did before with this wall here. So let's try to actually let's try to disconnect it here and create a portal later, a little bit later. I want to use this smooth step node, right? Remember, we subtracted some value here to create this like a smooth transition between smooth transition on the edges of the pattern. So let it be something like this, and create a slider and call it puddles intensity. Just put it here. Oh, maybe we don't need to create a portals. Let just be. No, let's just create it, because later we are going to use it in normals and roughness, so it will be more suitable to use portal node here. Let's call it puddles mask. Create a portal out. Save it. Yeah, right now we can control the amount, but as you can see, because of this action here, because we subtracted 0.2 at the 0 value of puddles intensity, we still have these small pieces of dark color, and what we can actually do, we can just try to we can just try to rearrange, for example, rearrange this puddles intensity slider. We know that we did it from 0 to 1. We made it from 0 to 1. And right now we can just use minus minus 0.2, but I suggest to use additional parameter because for example, we would like to control the contrast of the border of the puddles, right? So let's call it puddles contrast. And this puddles contrast is actually this value here, 0.2, right? So we don't need to type it manually. And we know that we need to subtract it from X value from the mask, right? So let's create a subtraction, oh sorry, not subgraph, subtract node. Let's choose X here. And let's subtract this puddles contrast. This result will go here. And this, actually, let's hold it. And this value of the contrast will go into the out range minimum, and the maximum, let's just leave it as 1 as it was before. And this is rearranged puddles intensity parameter, so we use it here into the smooth step node. And I believe if we save it, it should become better. Yep, at 0 now we have nothing, and we can control. Oh, sorry, no. Yeah, I just confused this intensity, but at 0 it is almost fine. I believe maybe I did something wrong. Just a second. I just check it. Puddles contrast goes there. Oh yeah, sure. We need the negative number here, so we can use some math here. So probably just minus X will do. Yep, right now it works perfectly. We can control the contrast of the border of this pattern, right? And we can control the amount of these puddles. And with 1 we have full covered surface, and with 0 we have nothing. Okay, so right now I want to control the roughness of the surface, right? Because I want the puddles to be pretty glossy. Let's go there. And actually, right now, remember about the moment with the opacity of albedo and the overall opacity. So right now, we can control roughness of our puddles, leaving this parameter here, and just mixing it. Oh, we actually, yeah. I think we actually don't need to mix it with anything. We can just use our mask as an opacity for roughness here. And I believe this will be fine. Let's try it out. Save it. Yeah, it works good enough. So out of our pattern we have roughness from the beneath layer of the asphalt or something concrete, and we can control the roughness of our puddles, but still I don't like that we have this normal here. Probably let's assume I want here in the center of the spot I want the water surface like a flat water surface, and I want this to be I want these puddles have flat normal, right? So we actually, I believe we can delete the normal texture for the puddles. Oh no, let's just leave it, because by default it is just a flat surface, right? And it will be pretty handy, because we only need flat surface. Let's connect it with normal, and let's use the same mask with an opacity normal, and I believe this will give us the pretty nice result. Nope, not now. Let's see why. Yeah, I forgot one thing. I'll show you right now. When you work with Decal PBR type material, there's actually is a normal blend mode, and I believe that we have a just not a bug but a mistake here, because these two modes should be vice versa. So this should be in additive mode, and additive mode, I suppose it will work just like I wanted. Yep, that's it. So it's just a mistake there in the interface, but right now I believe I have like a perfect result. I can control the puddles contrast like this. I can control the amount of our puddles. I can rotate them. I can move this area. I can create additional areas here, and it will work absolutely fine. Oh yeah, so basically right now our contrast works in the opposite. This can be easily changed by adding a negative sign here, or multiplying it, or just yeah, multiplying it by -1 or something. That's it about the decals, I believe. So let's just leave it here. Okay, so there's actually a transparent type of material here, but so if we go, let's just go somewhere. Let's just create another material. Yeah, in the types of material, we actually have a transparent PBR, which also a pretty important thing. But right now I can only say about the different blend modes here. The thing is, we want to, when we talk about transparency, we actually mostly want to talk about glass material, but I believe we decided that this will be the separate topic for video tutorials or next streams, because it is really very complex topic. We actually have a sample, probably someone already saw it. In this sample we have, I believe, 5 or 4 types of glass material, and there's a text here which actually tells you that some of these materials have like lower performance but higher quality, and vice versa. And these materials, they're actually very so first of all, they're actually in some kind of work in progress, but the thing is, they're very difficult and complex, and in some types of this glass, there is sorry, I forgot the word. So basically, when you work with refraction and reflection, and you want it to be within a transparent material, it will be pretty difficult thing to achieve, and we believe it will be better if we try to create like a separate tutorial on it, and we believe it will be more effective. So right now I won't cover glass or something like that because of the format of the stream, and because it's actually just the basics of working process with the material graph. But I wanted to show you pretty important thing regarding the material subgraphs. So actually, when we create a material subgraph here, let's open it up. It's a separate file which can be used as a single node with custom inputs and outputs. When we open it here, we have by default input and output, and by double clicking here we can add some inputs, choose the type of it and name it, add additional, and the same goes for output. Basically you can have a pretty complex complex net of nodes here, and especially when you want to reuse this part of a code, this part of material, right? You can pack it into the subgraph in this way and use it as a single node. If we just, let's, I don't know, try to add something, multiply this one by this one, and we want the result here, we can save it. And if we work with the base material graph, we can just drag and drop the m subgraph file and it will work fine. By double clicking on it, we can assign, we actually can create a subgraph node from here, from this menu. Oh, sorry, subgraph, material subgraph. Yeah, by default it just choose the first available one, but if we want to this node to use some different subgraph material, we can just choose another one through this menu, and we can go to this file, which is here. Actually, it is already selected. This is about a custom subgraphs, but pretty important thing to know that we have already prepared sometimes pretty complex subgraphs which we ship with our SDK. And if you create a subgraph here, actually few of these subgraphs, if we go to core, to subgraphs, you can see it here. And for example, we see this black body and subgraph, right? We can just start to type the name, and actually it's not like a separate single node. If you double click on it, you can see that this is actually a subgraph. And I will show you right now like just a couple of them, like cool ones. So for example, probably you know about this approach to create interiors in windows of the buildings. basically, I believe we have something. Yeah, there's an approach when you just create a box inside, inverted box inside of the building, and just project simple textures on his sides, on its sides. But there is an interior parallax, which this approach became like pretty popular in video games in recent couple of years. You can see that the image actually is getting distorted here. But it's actually pretty cool. It's enough to create this illusion of volume inside of the windows. So let's just recreate this using this using our subgraphs. So basically, let's go to, I have textures for interior here. Let's create a material which will be named interior parallax new. Let's create a child material. Let's assign this child material to our windows. So you can press edit graph here on the child material. Yeah, let's close the previous ones. Talk about delete metalness. And what we want to do, we want to have this interior parallax subgraph. Let's type interior, and as you can see, we have interior mapping cube map and texture 2D. The difference is with the cube map, you will have a little bit less distortions within this interior, but it will take you more time, obviously, because you need to create this cube map texture. And we actually ship this texture 2D interior mapping, which will allow you to use just this simple 2D texture. It should just be created in a special way, so with the same special perspective, like here on this texture. But it's much more easier, and you can use actually atlases of them. So for example, you want this texture to be 4 different different interiors, but of course you will need to just design the proper way to cut this in 4 inside the material graph, and use to force your windows use, for example, I don't know, randomly all of these 4 interiors. So, but let's just continue with this. What this subgraph actually does, it gives you finally the result. So, so we need to use, let's just change the name of this albedo color to interior albedo. Interior albedo. Okay, let's oh, I changed the color, sorry. Interior albedo, let it be just dark, or no, let's say color. Okay, and here it'll be interior albedo. Okay, so we can just put UV here. The main thing here, the main moment here, is that this object, this geometry of windows, actually is unwrapped, or was unwrapped in a way that in a way to be fit this texture of these frames of windows, right? So these UV islands of these glass surfaces are somewhere here, but with this texture we need this, for example, separate window mesh to fit the whole UV space, right, from 0 to 1 on both axes, and to actually be oriented properly, the same as the texture of interior. That's why you actually need to prepare your content. I've just opened this building in one of the 3D software and just separated windows and unwrap them properly and save it this UV into the first UV channel, or second as you call it. So that's why we have this UV input, and we can call vertex, we can create vertex UV1 node and just put it here. Let's just save it and assign an interior here. Here we go. We already have this distortion, this effect of volume. But we need to mix it with the frame, right? That's why we can lerp this result. I actually have an alpha channel with within this texture of this, I don't know, building walls, and this alpha channel actually contains a value that tells me where the glass is. So let's just try to create a separate texture 2D parameter and call it frame albedo, for example. Frame albedo here, duplicate SampleTexture node, and don't forget that here with the frame we use like the first or 0 channel of the UV, right? So we don't need to change anything here. Let's go here. We need to blend it this, and we need an alpha channel, right, of this texture of frames to use it as a mask blending. Sorry. Okay, that will be okay. And then let's put it into the albedo, save it. Let's see what we have. We need to assign an frame albedo texture. Okay, that worked. What else? In the inputs of this node we have parallax multiplier. So let's create a slider parameter. Let's call it depth. Save it. Right now we can tweak the depths of the room. Let's do something like this, 1.3, 1.4. And we have this multiplier of the color. We can just make it a little bit darker, and I want the normal map of the frame to participate here in this material. That's why we can lerp. Oh, actually we can just assign a normal map from the window frame, right? Yeah, that's okay. And roughness or shading texture. Let's just create shading texture 2D parameter. Maybe get it here. I don't really want to tweak the roughness, so let's just put the texture here, the Y component of the texture, or G channel, and assign shading texture here. Yep. Right now we have a proper reflections on the glasses. I mean that they became a lot more glossy. And to fake the effect of the darkness in the room, we could use an additional subgraph which is called Fresnel. So what we want is we want the interior to be darker at the sharper angles, like here, right? So the Fresnel will just give us the mask depending on the angle between the vector of the camera and the normal of the surface of the glass. What we can do is we can just multiply lerp. Just let me think. I think we need to lerp it. Lerp it. Yeah, let's lerp it with float 1 absolute dark color. So let's lerp this one interior albedo, right? With absolute black color by the mask of Fresnel, and put it here back. And we can control the power, so let's just create a slider, Fresnel, power, put it here, sorry, and save it. Let's see what we have. Yeah, right now it becomes darker. We even can see it within the buffer, debug buffer of albedo. We can control the power of Fresnel to make it more darker, the edges, at the sharp angles. That's one of the cool things. What else with subgraphs? I remember clearly that we have, let's just play it. Yeah, that we have, for example, let's go inside the material of leaves. We have a subgraph called something like animation, tree animation, yeah, for example, and a separate animation for grass, but let's just try with tree animation. It has a lot of inputs here. That is that control that like speed and amount and offset of the animation separately for leaves, branches, so with the big sized noise or small size for leaves and something like that. And of course you can use a lot of things to be input here. For example, 3D textures even. I believe we have a sample for that too. So let's just, as you can see, yeah, it has an output of vertex, offset, tangent space. We have vertex, offset, tangent space input here. We can just try to connect it and see what it does. So simply at that. What else? Oh, I wanted to show you depth fade subgraph. Yeah, just let me try. I believe I have this. Yeah, so let's create like a primitive sphere, for example. Let's size it a little bit. And let's create a material, call it depth fade sphere. Open it up, delete, let's delete everything and change it to actually transparent PBR. Yeah, because if we want to work with depth and we want some objects to be transparent in some areas, of course it should be type of material mesh transparent PBR. And basically, if we try to type depth fade, we have this only one input. Let's just call it depth fade. Connect it here, and let's go to opacity and save. I believe we need some color, right? Let's just make it white. Save. Oh yeah, we need to create a child material and assign it. Yeah, don't mind that it became this brownish, because it is transparent and it reacts to the light and to the global illumination baked in volume texture differently. It doesn't matter right now. Well, actually, just to be just to see it more clearly and brighter, let's create some kind of color. We already have a parameter of color here, and we can actually put it into the emission. But we need, if we want to use this color into the emission, we need this albedo color to be fully black, and we need to use 3 first components of the color through the sRGB inverse and put it into emission, save, and let's just try to choose the color here. I don't know, something like that. So the thing is with depth fade that we can control the transparency of the object depending of the intersection, as you can see. So where it intersects, it becomes less visible, and you can actually just inverse it. For example, inverted, yeah, sorry. And you can use it in combination with Fresnel, as you remember. Let's just add something like Fresnel power to control it here. What we want to do, probably let's just multiply it. And try to see what we have. Oh, okay, yeah, that's nice. We can control it. Oh, it's too much. Something like that, you know, to create something like a especially when you add moving texture, offsetting texture with some cells, we'll be able to create some kind of a energy shield or something like that. Let's suppose I want this to be like inverted. Maybe I can just try to invert it. What do I have? So there's a lot of free space to experiment with this. Maybe if I just try to invert it like that, what do I have? Maybe we need to multiply it. Not multiply, but add this. Try to add this. Minus, maybe accelerate. Oh yeah, we get the little bit different result. Right now we have this more brighter part where the object intersects other objects. So that's it. I believe we are done with basic stuff. I'll try to maybe to look at some questions from you. Hello, in which version of UNIGINE SDK this version seen available? Unfortunately, it's not available. It's like a side project. People, can you tell if there's any games on this engine? Yeah, there are a few games on UNIGINE. You can, I believe, just Google it. Oh yeah, why are the nodes pure white green? Should they show a preview of the maps? Yeah, they should. Material graph is in some way still is work in progress, and we know about this particular thing, and yeah, it will be fixed. Actually, not fixed. It just should be done properly. Yeah, there are. Sorry, missed it. Yeah, texture arrays, but it's not the topic. Not the topic right now. I believe it's more complex thing, and we'll cover it later, I hope. Okay, I believe this is it. Just a second. 2.16 will be released, well, hopefully during the next couple of months. Oh, about the like a clear code or something like that. Right now we're working and thinking about the realization of this multi-layering materials. So as you've mentioned, right now we need to lerp and blend these components like albedo, roughness, normal, and something like that separately. But we're working on it. Right now, the easiest way to create a car paint, for example, is just use the doubled geometry for the whole car, which is painted, like the painted part, and the upper geometry will be transparent in an additive mode, and you will have two different BRDF, so basically two different highlights, and well, it is actually how car paint works. So it's just not very convenient to work with to create it. How many draw calls can UNIGINE handle? You know, actually, we didn't count, but sometimes, usually it is okay inside the profiler too. Here in rendering, I believe we have these dips, right? Sometimes, well, usually when you go over like a few thousand, it becomes like not very bad, but we just try to keep it under or below like 2000, for example. Yeah, I believe this is it. Thank you very much for your attention. I hope that we'll be able to create additional new video tutorials, to have new streams, because it would be very interesting to tell about like more complex stuff related to material graph editor, and to cover these topics really need